Hi everyone, welcome to your C++ learning platform where we teach you how to program in C++ using the step-by-step do-it-yourself approach. I'm IK your tutor on the platform. In our previous video, we look at decision making statement in C++ where we look at the if else statement, and today we are continuing the statement looking at the nested if statement. The objective of today's lesson is to introduce students to the nested if decision making statement needed to control the flow of a program. And at the end of the day, we'll also be implementing some examples of the nested if. So, what is the if else statement? An if statement can when you have an if statement, it can have an optional else if statement, and if we use this else if statement when we want to check various conditions using a single if else if statement. Like for example, you have a case where the possible outcomes can be A, B, C. That is, A can come, B can come, C can come, but at any point in time, one of them comes. But it can be A, B, C, D, E, F. But at any point, one of them will come. Then we use the if else if statement to check these possible outcomes. So when you want to implement the if else if statement, there are some points that you need to keep in mind and to know, and I'll take you through these points. The number one is that note that every if statement can have an else. If you are using the if else if statement, when you have an if statement, the if statement can have an else statement. But then the else statement, when you are implementing the if else if statement, the else statement that you want to implement should come after the else if statement, meaning that the else statement should be the last or the default statement. You should not the else statement should not come before an else if. Are you getting it? So the else statement should be the last. Okay, don't get yourself confused. When we start with implementation, you will get to know this point. Then the next point is that an if can have zero to many else if. That is what we are saying, that the number of else ifs that you can implement is not limited. You can implement as many as you can. You can also decide to say that there won't be any else if. So, but then if there are else if you want to implement thousands or billions of else ifs, all these else ifs should come before the else statement, which means that the second point here, comes to confirm the first point, which says that there should be an else. You can have an else statement, but it should be the last. It should come after all else what if statement. And the last point, the second point here, is also saying that you can have so many what else if statement, but all these ones should come before an else what statement. So this is also confirmation of this. Then the last one is saying that when one of the else if statement is true, the remaining ones should not be tested. So what we are saying, that if let's say you ask the guy to buy you wachi, and you told him that if there is gari, you should buy gari. Else if there's macaroni, you should buy macaroni. Else if there is what egg, you should buy egg. Or else if there is what fish, you should buy fish. Which means that the first priority is to buy gari. So if there is gari, buy gari and leave all the rest. You only go and buy macaroni when there is no gari. So what we are saying, that once the first if succeed is true, the remaining ones should not be tested. So immediately the guy realized that there is gari, he will not buy the rest. Okay, let's say that you send another guy to go and buy you food, and he said, okay, go and buy me food. If there is fufu, buy me fufu. If there is no fufu and there is what, let's say rice and stew, buy me rice and stew. If there is no rice and stew, buy me yam. If there is no yam, buy me, let's say, gobe. or Yokogari Gobeli. And you realize that when the guy goes there, immediately there's fufu, he will buy fufu and forget about checking whether the rest are there. That is what we are saying. That is how the else if statement works. So if we are looking at the stratogram of the else if chain, we realize that we have the first expression, if expression, to check. And if expression we know can be true and or it can be what? False. So if it is true, what is the statement? So go and buy me food. If there is food, buy me food. So you buy. If there is no food, check if there is wachi. So it's false. There is no food. Do we have wachi? Oh, he check. Okay, there's wachi. He buy. Oh no, if there is no wachi, then check if there is what? Let's say fried yam. So he come. It's false. There's no wachi. Check. Do we have fried yam? Check. Okay, fried yam is there. I buy. If there's no fried yam, check if there is let's say another thing. So the check can go on, check can go on until we get what actually wants. So realize that once we have so many things to check and just to buy one out of them, we cannot implement this one with our previous tutorial, which is the if else statement, unless we use the nested what if statement. So what is the syntax? Let's see. The syntax is we have what the if statement, we have the Boolean expression. So the first one we have the if open parenthesis Boolean expression to check, we close the parenthesis, and if this Boolean expression execute true, we will do what is in this portion of code. If it is false, we come and check the next statement, and then if that one is true, we execute. If it is false, come and check. So realize, as we said in the previous point, that there can be so many what else if, but all this else if should come before what the else statement. And we also said that point one, there can be else, but the else should be the last one to come. So if the last point was saying that if this else if is true, meaning that all these ones here will not be checked, we are done. The system will end here because this one is true. That was what we were saying there. So let's see an implementation. Let's see, we are writing a C++ program that gives the number of hours. That is when we are giving the number of hours of an employee, where we and his hourly wages, we compute his weekly pay, count any hours over 40 as overtime at a rate half hourly rate. So what we are saying that we just doing a recap. We are implementing this one using the if else statement. So I want to refresh your mind with what we did on our previous video with the if and the if else statement. So we have to write a software that will calculate the pay of the weekly pay of somebody if we know the total hours he has worked in a week and how he's being paid per hour in a week. So let's see what happens. So we'll need the input. As I've said, your ability to always bring a program into how the computer function, input and output, you have solved the problem. So in this case, you realize that the number of hours worked is an input that your system requires, and the hourly wages is also an input. So there's going to be two input variables, this and that. So here we see the input hours worked, which we are saying that is what HRW, and hourly wage, which we are saying is HW. So the next thing is to do the processing. Now let's assume that the weekly pay, we are denoting it to WP. We are initializing to 0. So if hours worked, remember this hours work here. So if hours worked is less or equal to 40, meaning that the person has worked either less than 40 or equal to 40, then of course his pay will be equal to his weekly pay will be equal to hours work times what hourly wage ID. Now remember that they said that if he works more than 40, then he's going to get a bonus of the overload, which is going to be the overload hours times half the hourly rate. So we are saying that if the person has not worked less or equal to 40, then it means that he has worked more than 40. So if he has worked more than 40, then we'll first calculate the first 40 hours work. So the 40 hours work will be 40 times the hourly wages. Then plus, we want to find the extra hours the person has worked. So the extra hours is going to be the hours he has worked minus. So let's assume that the person worked for 50 hours. So he worked for 50. So here will be 50 minus 40. So which will give us 10. So here we are going to get 10. So it will be 10 times 10 times the sorry, here should have been 0. 10 times is 0.5, not so we have 10 times what, the hourly wages times what, 0.5, because the rate is half that of the hourly wages. So we first multiply 40 by the wage to get the first 40 hours he has worked with. Then the remaining hours we multiply by the half the hourly what wages. So that is what we are doing here. And when we are done, we print his what wages. It's very easy and simple. So let's see what is happening in the code. So we of course we use our input and now we hash include our input and output our string. We have using the namespace, we have our int main. We declare our local variables. We have the float representing the hours work. We have the hourly rate. Then we have what, weekly pay. This portion I'm just adding it to do some deco in the programming when the person run. Of course, I want to tell the person that this program is used for calculating your paycheck, and that is also that one is not necessary, or you can remove it if you want. So we come straight to look at the code writing. So first we have to prompt the user to enter the hours he has worked, and then we use the cin to pick the hours he has worked. Now then we also tell him to enter his hourly rate here, and we use the cin to pick the hourly work rate. So first one, we look at if the hours worked is less or equal to 40, then straight for the weekly pay is the hours worked times the hourly work rate. Else else it means that if the hours input, if it is not less or equal to what, 40, then it means that it's greater than what, 40. So else we calculate the pay due to the person for the first 40 hours he or she has worked, and then we subtract 40 from the hours worked to know the remaining hours, and then we multiply by half what, the rate. So when we finish, we just write you worked this hours, and your salary is equal to what, weekly what, pay. So remember, if the hours worked is more than what, 50, it's more than 40, you first have to calculate the salary due to the person by the normal 40 hours rate, and then you find the difference, the extra hours he or she has worked, and calculate find the amount due him by calculating it at half rate of the normal what, hours. Okay, so let's see another example. Here we looking at the if else if nested if statement. So here let's say we have int a, which is equal to 50, a local variable. Then we are checking. So if a is equal to what, 10, we are saying that see out value of a is to 10. Else if a is equal to what, 20, that is if the value whatever stored in a is the same as 20. Don't forget, this is not we said in the previous video, equal, which is comparing. So you can see that we are testing the value of a at different what, instant here, another instant, and then we are saying else. So you can also keep on testing, like if the value of a is 10, if it is 20, if it is 30, if it is 40, and if it is 50, whatever, you keep on testing. But remember that if you want to implement the else statement should be the last statement, as we have discussed in the condition. If you run this code here, you're expecting to get a value. This is the output. Value of a is nothing matching, because if you look at the value of a is 50, it's not 10, neither is it what, 20, neither is it what, 30. So it will come to the default value, which is what, it's not matching. So you can copy all the codes and implement them. Of course, I want you to type it, so the codes are in images, so try and type it. So as you are typing, become familiar with the syntax and the application running. Okay, so let's see another example, a simple example. We all know what are leap years, so we know, everybody know what a leap year is. We are saying the leap year is any year divisible by 4 unless it is divisible by 100 but not 400. So if we pick a year, if that year is divisible by 4 and that year is not divisible by what, 100, then it's a leap year. Or else if it is divisible by 4, and also divisible by 100, and then by 400. It's also a leap year. We are writing a program to tell whether a year is a leap year or not. So let's try to see what happens. Let's try and break this to our input and output, and let's see. So before then, I want to just give you some deeper explanation so that you can understand the concept of what we are doing. Leap years are leap years are any year that can be exactly divided by what? 4, such as 2016 can be divided by 4, 2020, 2 days, right? Except if it can be exactly divided by what? 100, then it is not a leap year. What we're saying that if that year is divisible by 4, and that same year is divisible by 100, then you have to check again. Then that year is not a leap year unless we do a third check. So we say except if it can be exactly divided by 400, then it is a leap year. So if the year can be divided by 4, it can be divided by 100, it can be divided by 400, then it's a leap year. But then if it can be divided by 4 and it cannot be divided by 100, it's also a leap year, right? So we are saying that the year is divisible by 4. That's the point. And it's exactly also divisible by what? 100. And it's also divisible by this. Then it is a leap year. But if it is also divisible by 4 and it's not divisible by 100, it is a leap year. So immediately it is divided by 4 and it's also divisible by 100, then you have to do the next testing whether it is also divisible by what? 400. So let me put this in a simple way for you to understand. So let me see, looking at this is the input, right? Our input is the year, and then we break it to our processing and what? Our output. So let's see what is going to the processing. So the processing first is the year divisible by 4 and not divisible by 100. So when it's divisible by 4 and not divisible by 100, you can say that year is a leap year, right? If the year is divisible by 4 and not divisible by 100, it's what? A leap year, right? Then if it is divisible by 4 and divisible by what? 100, but also divisible by what? 400, it's also what? A leap year. So it's divisible by 4, divisible by 100, divisible by 400, then it is a leap year. Okay. Then if it is divisible by 4 and divisible by 100 but not divisible by 400, then it is not a leap year. So there are 3 possible testing. If it falls in this, it is a leap year. If it falls here, it's also a leap year. And when it falls here, it is not a leap year, right? Okay, so let's see the coding aspect. So how do we transfer it to C++? So of course, as I said, this portion is just to prompt the user. This side is just to prompt the user what you want to do. So now we declare a variable as integer as what? A year, and we set it to 0. Then we can enter the year you wish to test. So we see in and pick in the year. Now we do the testing. If the year is divisible by what? 4. Remember that we use the modulo when we are interested in divisible. Means that when you divide, the remainder is 0. If a number is divisible by 4, means that when you divide, the remainder is 0. And in our previous video, we have said that we use the modulo sign when we are interested in the remainder of integer division. So here, year modulo 4 equal 0 means that when you divide the year by 4, is the remainder the same as 0. So you can see that is that. And if again that same year is divisible by 100 and the remainder is not 0, remember that we said that a year is a leap year. Let's go back for you to see what happens. We say a year is a leap year when it's divisible by what? 4 and not divisible by what? 100. Means that when you divide it by 100, the remainder will not be what? 0. So we are saying that when that year is divisible by 100, the remainder is not 0. Then that year is what? A leap year. Then we go to the next case. Else if the year is divisible by what? 4 and that same year is divisible by what? 100, and that same year is divisible by what? 400, then it is what? A leap year. Back again, when the year is divisible by 4 and is divisible by 100 and also divisible by what? 400, then it is what? A leap year. So that is what we are testing also here. Then the last one we said, else if the year is divisible by 4 and divisible by 100 but not divisible by what? 400, then it is not what? A leap year. So we come here, we come here again and we say that here the year is divisible by what? 4 and also divisible by 100 but not divisible by 400, then it is not a leap year. So I hope you've gotten the point. So we have used the else if statement to implement a simple application that can test whether an input year is a leap year or not. Let's see our last example for the day. Example 4. A professor generates letters grades using table 6.3, which is this table. Write a C++ program such that given a numerical grade, print the letter. So we are writing a grading system such that when you input a number, when you input the percentage score or the marks of the student, the system will grade whether the student had F, whether he had what? D, whether he had what? What do you call it? C or B or what? A. So if you look at the system, it says that if the number is within what? 0 to what? 60, meaning that if it is 1, 2, 3, 4 up to 60, so 0, when you score 0 up to 60, you are F. And when you score anything from 61 to what? 70, so it can be 61, 62, 63, you can continue up to 70, and same for this one also. And we have to write a C+. So the number can be this and can be that. I get, meaning that the number can be the mass score. If the mass score is, let's say, greater or equal to what? 61. I get me. And the same marks is lesser or equal to 70, then you are within this frame. So you can see some inequalities here. So now let's see what happens in the C++ transformation. We are transforming that into C++. So we declare a float here to represent the score of a student, and then we use a car to represent the grade. Remember that in our previous video I show you how to initialize what? Car data type. So here we have initialized the car data type. So we print on the screen, please enter your marks, and then we see in what? The marks here with this line of code. That's the get aspect if we're writing our pseudocodes. Okay, so now we do the first test. We are saying that if the marks is less or equal to what? 60. So the marks the student have entered, is it less or equal to 50? Because 60, because the man said that from 0 to 60 you are going to score what? F. So once the marks you have entered is less than or is equal to 60, then of course you are in the F column, right? Okay, so now else if the marks is greater or equal to what? 61. Remember the next point was from 61 to where? To 70. So if the marks you have entered is greater or equal to 61, 61, 62, 63, and the same marks is less than what? 70, so the marks is within this bracket. It is greater than 61, is greater or equal to 61, but it is less or equal to what? 70, and then of course the grade is equal to what? D. And the same thing if the marks is greater or equal to 71, and the same marks is less or equal to 80, then your grade is this. And we do same for this and for that. So when we finish, we say print out, you entered this marks and your grade is this. You can follow this, code it yourself, and also do more, play with it, try more, bring your own ideas to make it more beautiful and attractive and user friendly. We thank you for watching our tutorial for the day. I hope that this tutorial that you have watched will be a blessing to you, and that you will become more perfect in your programming. Please again, if you love our videos, if our videos are helping you, we're encouraging you to subscribe to our channel and share the videos with your friends, and always visit our channels for more videos, because we are preparing videos for you. May God bless you, may God help you, may God keep you safe till we meet again. Bye bye.